unit will not operate if the grounding wire, which is typically green or gray, becomes disconnected from a 3-wire, 240-volt alternating current unit. The grounding wire serves a critical safety function by providing a low impedance path for electrical current to flow back to the source in the event of a fault. This path ensures that overcurrent protection devices, such as circuit breakers or fuses, will quickly trip, interrupting the flow of electricity and preventing electrical shock hazards or equipment damage. Without a proper grounding connection, a fault current could flow through unintended paths, such as the metal chassis of the appliance, or, more dangerously, through a person who comes into contact with the energized appliance. This is because electricity always seeks the path of least resistance to return to the source, and without a dedicated grounding conductor, the person could inadvertently become part of the circuit. Grounding ensures the voltage potential of metallic parts is near zero with respect to ground. This minimizes the risk of electric shock if someone touches the appliance while a fault exists. In addition to safety, the grounding wire also helps protect the AC unit itself from damage due to electrical surges or faults. A properly grounded appliance is less susceptible to electrical problems such as short circuits, insulation breakdown, and fires. The grounding system helps to dissipate static electricity, which can build up on the appliance and cause damage to sensitive electronic components. The National Electrical Code, or NEC, specifies requirements for grounding and bonding electrical systems to ensure safety. Proper grounding and bonding are essential for the safe and reliable operation of electrical equipment. The grounding electrode conductor connects the grounded conductor of the electrical system to a grounding electrode, such as a ground rod or water pipe. This provides a path for fault current to flow back to the source. The equipment grounding conductor connects the non-current carrying metal parts of electrical equipment to the grounding system. This includes the metal chassis of appliances, enclosures, and raceways. The equipment grounding conductor provides a low impedance path for fault current to flow back to the source, tripping the overcurrent protection device. Bonding is the process of connecting all metal parts of the electrical system together to create a single, continuous electrical path. This includes metal conduit, metal enclosures, and metal equipment. Bonding ensures that all metal parts are at the same electrical potential, minimizing the risk of electric shock. The size of the grounding wire is determined by the size of the circuit conductors. The NEC specifies the minimum size of the grounding wire based on the ampacity of the circuit. It is important to use the correct size grounding wire to ensure that it can safely carry the fault current. The grounding wire should be securely connected to the grounding terminal in the AC unit and to the grounding system. A loose or corroded connection can prevent the grounding wire from functioning properly. The grounding system should be tested periodically to ensure that it is functioning properly. A ground impedance tester can be used to measure the resistance of the grounding system. A high resistance indicates a problem with the grounding system. If the grounding wire is disconnected, it should be reconnected immediately by a qualified electrician. Do not operate the AC unit until the grounding wire has been properly reconnected. Attempting to repair the grounding system yourself can be dangerous and should only be done by a qualified electrician. Improper grounding can create a serious safety hazard. Always follow the manufacturer's instructions and the NEC when working with electrical equipment. In summary, the grounding wire is an essential safety component of a 240-volt AC unit. It provides a path for fault current to flow back to the source, protecting people from electrical shock and preventing damage to the equipment. A disconnected grounding wire renders the unit inoperable and creates a serious safety hazard. The grounding system is designed to protect against electrical shock by providing a low resistance path for fault currents to return to the source, causing the overcurrent protection device, such as a circuit breaker or fuse, to trip and to energize the circuit. This prevents dangerous voltage from appearing on the metal parts of the appliance, which could be touched by a person. Without a proper ground connection, a fault current could flow through a person's body if they come into contact with the energized appliance, resulting in serious injury or even death. A ground fault occurs when an ungrounded conductor comes into contact with a grounded surface, such as the metal enclosure of an appliance. In a properly grounded system, the ground fault current will flow through the grounding conductor back to the source, causing the overcurrent protection device to trip and de-energize the circuit. This prevents the fault current from flowing through other paths, such as a person's body. The grounding system also helps to protect the appliance itself from damage due to electrical surges or faults. A surge is a sudden increase in voltage that can damage sensitive electronic components. The grounding system provides a path for the surge current to flow to ground, preventing it from damaging the appliance. Static electricity can also build up on appliances, especially in dry environments. The grounding system helps to dissipate static electricity, preventing it from damaging sensitive electronic components. The NEC, or National Electrical Code, specifies the requirements for grounding and bonding electrical systems. The NEC requires that all electrical equipment be grounded in accordance with its provisions. The NEC also specifies the size and type of grounding conductors that must be used. Grounding electrodes are used to connect the grounding system to the earth. Common types of grounding electrodes include ground rods, ground plates, and metal water pipes. The NEC specifies the requirements for the installation of grounding electrodes. Bonding is the process of connecting all metal parts of the electrical system together to create a continuous electrical path. This helps to ensure that all metal parts are at the same electrical potential, minimizing the risk of electric shock. The NEC specifies the requirements for bonding electrical systems. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing through a circuit and detect any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI will trip and de-energize the circuit in a fraction of a second. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or FSIs, are devices that are designed to protect against electrical fires. FSIs detect arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. If an arc fault is detected, the FSI will trip and de-energize the circuit. FSIs are required in many locations, such as bedrooms and living rooms. Electrical safety is an important consideration for everyone. By following safe electrical practices, you can help to prevent electrical shocks and fires. Always use caution when working with electricity. If you are not comfortable working with electricity, hire a qualified electrician. In addition to the grounding wire, other safety features are often incorporated into 240 volt alternating current units to enhance safety and prevent electrical hazards. One common feature is overcurrent protection, which is typically provided by a circuit breaker or fuse. This device is designed to interrupt the flow of electricity if the current exceeds a safe level, preventing overheating and potential fires. The circuit breaker or fuse is sized to protect the wiring and components of the AC unit from damage. Another safety feature is thermal overload protection, which is designed to protect the motor of the AC unit from overheating. The thermal overload protector is a temperature-sensitive device that will trip and shut off the motor if it gets too hot. This prevents the motor from being damaged due to excessive heat. Many AC units also have a disconnect switch, which allows you to easily disconnect the power to the unit for servicing or repairs. The disconnect switch is typically located near the AC unit and should be clearly labeled. It is important to always disconnect the power to the AC unit before performing any maintenance or repairs. Double insulation is another safety feature that is often used in electrical appliances. Double insulation means that the appliance has two layers of insulation between the electrical conductors and the user. This provides an extra layer of protection against electric shock. Appliances with double insulation do not require a grounding wire. Surge protection is also important for protecting AC units from damage due to voltage spikes. A surge suppressor can be installed at the electrical panel or at the AC unit to protect it from surges. Surge suppressors work by diverting excess voltage to ground, preventing it from damaging the appliance. Regular inspection and maintenance of AC units is important for ensuring their safe and reliable operation. The AC unit should be inspected regularly for any signs of damage, such as frayed wires, cracked insulation, or loose connections. The AC unit should also be cleaned regularly to remove dust and debris, which can cause overheating. It is important to have a qualified technician perform regular maintenance on the AC unit, such as cleaning the coils and checking the refrigerant level. Proper installation of the AC unit is also critical for safety. The AC unit should be installed in accordance with the manufacturer's instructions and the NEC. The AC unit should be properly grounded and bonded to ensure that it is safe to operate. If you are not comfortable installing the AC unit yourself, hire a qualified electrician. When working with electricity, it is important to always follow safe electrical practices. Always turn off the power to the circuit before working on any electrical equipment. Use insulated tools when working with electricity. Wear safety glasses to protect your eyes. Never work with electricity in wet or damp conditions. If you are not sure how to do something safely, hire a qualified electrician. In addition to these safety features, it is also important to be aware of the potential hazards associated with AC units. AC units can be heavy and difficult to move, so it is important to use proper lifting techniques when moving them. AC units can also be noisy, so it is important to wear ear protection when working near them. AC units can also generate heat, so it is important to keep them away from flammable materials. By following these safety precautions, you can help to prevent accidents and injuries when working with AC units. The absence of a grounding wire not only poses a risk of electric shock, but also makes the unit more vulnerable to damage from power surges and other electrical anomalies. These surges can damage sensitive electronic components within the AC unit, leading to costly repairs or premature failure. The grounding wire provides a path for these surges to safely dissipate, protecting the unit from damage. Proper grounding is essential for ensuring the longevity and reliability of the AC unit. Without a grounding wire, the AC unit may experience erratic behavior, such as malfunctioning controls or inconsistent cooling performance. This is because the electrical noise and interference that would normally be shunted to ground can instead disrupt the operation of the unit's electronic components. Furthermore, the absence of a grounding wire can create a potential fire hazard. If a fault occurs within the AC unit, the ungrounded metal parts of the unit can become energized, creating a risk of electric shock to anyone who touches them. In addition, the fault current can generate heat, which can ignite nearby flammable materials. The grounding wire provides a path for this fault current to safely flow back to the source, tripping the circuit breaker and preventing a fire. The National Electrical Code (NEC) mandates specific grounding requirements for AC units and other electrical appliances. These requirements are designed to ensure the safety of people and property. It is essential to comply with these requirements when installing or repairing an AC unit. The NEC specifies the size and type of grounding wire that must be used for different types of AC units. The NEC also specifies the methods for connecting the grounding wire to the AC unit and to the grounding system. It is important to consult the NEC and the manufacturer's instructions when working with AC units to ensure that they are properly grounded. If you are not comfortable working with electricity, it is best to hire a qualified electrician to install or repair your AC unit. A qualified electrician will have the knowledge and experience to ensure that the AC unit is properly grounded and that all electrical connections are safe and secure. Attempting to perform electrical work without proper training can be dangerous and can lead to serious injury or even death. Remember, the grounding wire is a critical safety component of your AC unit. Do not operate the AC unit if the grounding wire is disconnected or damaged. Contact a qualified electrician to repair the grounding system as soon as possible. The consequences of neglecting a faulty grounding wire can be severe, ranging from minor electrical shocks to serious injury or death. The grounding wire is not just a mere convenience, it is a vital safety feature that protects you, your family, and your property from electrical hazard. So, if you suspect that your AC unit's grounding wire is disconnected, take immediate action to have it repaired by a qualified electrician. Your safety depends on it. It is important to remember that even if the AC unit appears to be working without a grounding wire, it is still unsafe to operate. The absence of a grounding wire creates a hidden hazard that can strike at any time. Do not take the risk. Have the grounding wire repaired or replaced as soon as possible. The grounding wire is a small price to pay for peace of mind and protection from electrical hazards. In addition to the safety aspects, a properly grounded AC unit will also operate more efficiently and reliably. The grounding wire helps to reduce electrical noise and interference, which can improve the performance of the unit's electronic components. A well-grounded AC unit will also be less susceptible to damage from power surges and other electrical anomalies. So, grounding is not only a safety measure but also a way to improve the performance and longevity of your AC unit. When selecting a grounding wire for your AC unit, it is important to choose the correct size and type. The size of the grounding wire is determined by the size of the circuit conductors. The NEC specifies the minimum size of the grounding wire based on the ampacity of the circuit. It is important to use the correct size grounding wire to ensure that it can safely carry the fault current. The grounding wire should also be of the correct type. The most common type of grounding wire is bare copper wire. However, insulated grounding wire is also available. Insulated grounding wire is often used in areas where it is exposed to moisture or corrosion. The grounding wire should be securely connected to the grounding terminal on the AC unit and to the grounding system. A loose or corroded connection can prevent the grounding wire from functioning properly. It is important to inspect the grounding connections regularly to ensure that they are tight and free of corrosion. If you find any loose or corroded connections, tighten or replace them as needed. The grounding system should be tested periodically to ensure that it is functioning properly. A ground impedance tester can be used to measure the resistance of the grounding system. A high resistance indicates a problem with the grounding system. If you suspect that there is a problem with your grounding system, contact a qualified electrician to inspect and repair it. Proper grounding is essential for the safe and reliable operation of your AC unit. Do not neglect the grounding wire. It is a vital safety feature that protects you, your family, and your property from electrical hazards. Always follow safe electrical practices when working with AC units. Turn off the power to the circuit before working on any electrical equipment. Use insulated tools when working with electricity. Wear safety glasses to protect your eyes. Never work with electricity in wet or damp conditions. If you are not sure how to do something safely, hire a qualified electrician. Electrical safety is an important consideration for everyone. By following safe electrical practices, you can help to prevent electrical shocks and fires. The grounding system is a critical part of your home's electrical system. It is designed to protect you from electrical shock and to prevent electrical fires. Make sure that your grounding system is properly installed and maintained. If you have any questions about grounding, contact a qualified electrician. They can answer your questions and help you to ensure that your home is safe from electrical hazards. In addition to the grounding wire, there are other safety devices that can be used to protect against electrical shock. Ground fault circuit interrupters, or GFCIs, are devices that are designed to protect people from electrical shock. GFCIs monitor the current flowing through a circuit and detect any imbalance between the hot and neutral conductors. If an imbalance is detected, the GFCI will trip and de-energize the circuit in a fraction of a second. GFCIs are required in many locations, such as bathrooms, kitchens, and outdoor areas. Arc fault circuit interrupters, or ASIs, are devices that are designed to protect against electrical fires. ASIs detect arc faults, which are dangerous electrical discharges that can occur in damaged or deteriorated wiring. If an arc fault is detected, the ASI will trip and energize the circuit. ASIs are required in many locations, such as bedrooms and living rooms. These devices provide an extra layer of protection against electrical hazards. Consider installing GFCIs and ASIs in your home to enhance your safety. Remember, electrical safety is an ongoing process. Stay informed about electrical hazards and take steps to protect yourself and your family. By following these safety tips, you can help to prevent electrical shocks and fires. The absence of a grounding wire on a 240-volt AC unit not only makes it unsafe to operate but also violates electrical codes and regulations. Electrical codes are designed to protect people and property from electrical hazards. These codes specify the requirements for grounding electrical systems and equipment. Failure to comply with these codes can result in fines, penalties, and even legal liability. It is important to ensure that your AC unit is properly grounded in accordance with all applicable electrical codes. When selling a home, it is important to disclose any known electrical problems, including a disconnected grounding wire. Failure to disclose such problems can result in legal action from the buyer. A home inspector will typically check the grounding system as part of a home inspection. If the home inspector finds any problems with the grounding system, they will recommend that it be repaired by a qualified electrician. It is best to address any electrical problems before selling your home to avoid any potential legal issues. Furthermore, operating an AC unit without a grounding wire can void the manufacturer's warranty. Most manufacturers require that their products be installed and operated in accordance with all applicable electrical codes. Failure to comply with these codes can void the warranty, leaving you responsible for any repairs or replacements. It is important to protect your investment by ensuring that your AC unit is properly grounded and that you are following all of the manufacturer's instructions. The grounding wire is an essential safety component of your AC unit. Do not take the risk of operating the unit without it. Contact a qualified electrician to repair the grounding system as soon as possible. Your safety, your property, and your legal liability depend on it. The information provided in this narration is for general guidance only and should not be considered as professional electrical advice. Always consult with a qualified electrician before performing any electrical work. A qualified electrician will have the knowledge and experience to ensure that the work is performed safely and in accordance with all applicable codes and regulations. Do not attempt to perform electrical work without proper training. Electrical work can be dangerous and can result in serious injury or even death. Always prioritize safety when working with electricity. The grounding wire is a critical safety component of your AC unit. Do not neglect it. It is a vital safety feature that protects you, your family, and your property from electrical hazards. Remember, electrical safety is everyone's responsibility. Take the time to learn about electrical hazards and to take steps to protect yourself and your family. By working together, we can create a safer environment for everyone.